Hey, this is Vaslav Turacek talking to you today about scaling microservices with Azure Service Fabric. Now, before we dive into that, I want to take a moment to talk about what actually goes into a service in Service Fabric. Now, these are made up of what we call packages, specifically code packages. And in a code package, what you have is your executables and your DLLs and all of your binaries that you need to run your service. Now, these code packages are versioned independently, and you can have as many of them as you want. And the code packages don't actually have to contain binaries or anything to run. They can actually just be pointers out to a container image that's located in a container registry like Docker Hub or Azure Container Registry. In addition to code packages, you can also have configuration packages, and this is where you put your configuration settings, XML, JSON, YAML files, whatever you want. These are also individually versioned, and you can have as many as you want. And as you can see, the version numbers don't actually have to be numbers. You can use anything you want. So take all this together, package it up, and you get what we call a service package, and that itself also has a version. Now, when you take this service package and you want to deploy it to your Service Fabric cluster, so you stand up a cluster with any number of nodes and you run this command which says service create, and this is using our Service Fabric command line. And when you use this command, you specify how many nodes you want to run this service on, and that's what we call the instance count. And what this basically does is it takes that service package as a whole and deploys it onto each node, and it gives it a name, which we use as fabric:/URI scheme. And the important thing to know here is that the entire service package is deployed as a group. So if you have a situation where you have multiple containers that you want to run together, always on the same node, the way you would do that is you'd put those into multiple code packages in the same service package, and that way they always run together. Okay, so now let's talk about how this scales out. So I can take that existing service and I can do an update command. And the update command basically just says, I want you to change some of the parameters about how this service runs, but I'm not actually changing the code inside the service. And I can specify a new instance count. In this case, for example, I used -1. And -1 is just a special way of saying, please run this on every node in the cluster, given any placement constraints I put onto that service. Now I've taken advantage of all the nodes available, and now I probably want to add more capacity, and I can do that using this Azure command line, Azure CLI, and I can simply say add more nodes to my Service Fabric cluster. And because my service is running with that special instance count of -1, Service Fabric will automatically place it on those new nodes. And so that's the basic stateless scale-out story. Now, in this case, I've scaled it out as far as I can, but I might not be using up all of the capacity that I have available on the nodes. And so if I want to use more of that capacity with the same service, I can actually just run that same command again and create yet another instance of that service, and that takes the exact same code package, so it's the same code, it's just deploying it one more time and giving it a unique name. So now we have a way of scaling out, but we can also kind of scale up and make use of that capacity on the node. Now, in more complicated scenarios and larger applications, you typically have a large number of services, and they don't necessarily always run on every node. And so in this case, we have this concept called resource balancing in Service Fabric, where the idea is I want to make sure that the services that I do run on all these nodes, that they're kind of distributed evenly, and so that I'm making use of all the capacity evenly across the cluster. And by default, Service Fabric does this by simply placing the same number of services on every node. But in real life, my services are probably going to be using different amounts of different resources available on the nodes. So for example, one of my services may be using more memory than one of the others, and so maybe using up more of that. And so Service Fabric is going to kind of look at this and draw a line across the bottom and say that, well, it looks like node 2 is a little bit over capacity while node 5 here is being underutilized. And so Service Fabric will automatically do some resource balancing where basically it'll redistribute these service instances across the cluster so that every node is using roughly the same amount of resources. And so this is done automatically, but it's using what we call this feature called load metrics. And load metrics is just a way for you to report, your services to report to the system what sort of resources it's using. And these can be physical resources like memory or CPU or disk, but they can also be completely arbitrary resources such as the number of users in a queue or the amount of foods that you've instantiated. It doesn't matter. It can be completely arbitrary, and you can define as many of these as you want, and you can assign weights to them, and Service Fabric will take all of that together and decide what is the best way to distribute these services across the cluster. And so the point here is that I can scale out, but I can also make sure that I'm using up all the capacity within the cluster that I already have as efficiently as possible. And so now when you draw a line across the bottom, it's a little bit straighter and a little bit smoother. Now you can also combine this with scaling out, of course, by adding more capacity. And as you do that, Service Fabric will again redistribute the services you have to make use of that new capacity. And the more nodes that you have and the more services you have, the finer grained everything is, and the better job Service Fabric can do making sure that you're using up everything as evenly as possible. And once you've scaled out this way, you've now freed up capacity on these nodes, which of course allows you to create more service instances by again calling that command. And so now you can pack more work onto the existing hardware that you have. So that's how it works with stateless services. It works basically the same way with stateful services. The difference, though, there's a couple caveats. One of the main differences is that when you deploy a stateful service, because the data that you write into the service is located along with the service itself, you can't simply scale it out the same way. And the reason is because when you create this stateful service, you get what we call a replica set. And in the replica set, you always have one primary, and that's where all of your write operations are going. So while I could add more secondary replicas to this replica set, all the writes would still be going to node 1, and I haven't really scaled out in any way. And so what you do in this case is you generally create this service with a larger number of partitions. And so everything you see on screen here now is actually part of the same service. It's just been divided up into pieces, essentially, what we call partitions. And so now I have a primary replica on every node. And so now I've kind of distributed my workload a little bit by doing it that way. And similarly with stateless services, of course, some of your partitions may end up getting more traffic or they're storing more data than others. And again, you may have kind of an uneven distribution. And that's okay because Service Fabric will, again, proactively rebalance everything to make sure that you're utilizing the cluster evenly across all the nodes that you have. Now, here's where the caveat comes in. With stateful services, because you can't repartition anything on the fly and you can't necessarily add more replicas in order to scale out, you have this problem where if you add nodes where you get to a point that I can only put one replica on each node, you get to a point where if I add more nodes, there's nothing else I can put onto those nodes. And so we're kind of at a point where we reach what we call a scale limit. And that's as far as I can scale one stateful service at a time. And so the idea is that if you want to scale this further, you would create more service instances, and those can then be redistributed and balanced effectively. So to show how this all comes together, here's a reference architecture that we have out on GitHub that uses an IoT situation where I have a stateful service reading from IoT Hub, and it's basically pulling in device data. And I have a stateful service that is partitioned, and those partitions are each responsible for a portion of that data. Now, this stateful service has that same scale-out limit problem. So if we expand this architecture a little bit more, we can see now the stateful service, if I have that just doing routing of those requests as they're coming in and then sending them off to other service instances to do the actual processing, this allows me then to scale out those upstream services by adding more services over time to do that processing. So now I can scale pretty much as far as I want because there really is no limit to the number of services that I can create. So that's how that all kind of comes together in this reference architecture. So that should give you an idea of how scaling and resource balancing in Service Fabric works. If you want to learn more about Service Fabric, of course, come to aka.ms/servicefabric and come check out some of our other talks on Channel 9, especially this one about modernizing .NET applications using containers on Azure Service Fabric. Thanks so much for watching.